Number 16. So we've got to complete a table of values for, and if you can't see that very well, it's y equals x squared take away 3x. So I'm going to start on the positive side because the negatives are always a bit of a problem. Okay, so x squared take away 3x. 4 squared for this one, take away 3 lots of 4. So that is y equals 4 squared take away 3 lots of 4, which is 16 take away 12, which is 4. Now you can do that working for each one, or you can try and do it in your head. The next one, x is 2. Y equals 2 squared take away 3 lots of 2. 4 take away 6. It's negative 2. Now if you're not sure if you're doing it right, since we've got some values given to us, this one here is 0, this one's negative 2, if you give them a try, then you'll know if you're doing it right or wrong. Right, we come to this negative. I'm going to go y equals negative 1 squared take away 3 times negative 1. Right, negative 1 squared is 1. Now that I'm sure would be a problem for some people, doing negative 1 times negative 1 and getting negative 1, when two negatives multiplied together make a positive. Negative 3 times negative 1 is positive 3, or if you think about it, this takeaway here, just leave it where it is. 3 times negative 1 is negative 3. So it's 1 take away negative 3, so that's like 1 plus 3, which is 4. So this number here is 4. Now if you do it wrong, you should notice that your graph doesn't look right, so hopefully you do that in an exam as well. I'm going to plot some of them points. 4, 4 is there. What else have we got? We've got 3, 0 and 2, negative 2. 3, 0 and 2, negative 2. Now what? 1, negative 2 and 0, 0. Negative 1, 4 and negative 2, 10. And we should see a nice little curve like that. So draw a smooth curve through that. Right, when we get to here, the temptation is to do a very flat bottom to it. We do not want that. So we dip below a little bit so that it makes a nice curve. And there we go. Use your graph to solve the equation of x squared take away 3x equals 2. Well, this is a graph of y equals x squared take away 3x take away 2. So if y equals this, we're looking for where y equals 2. So if you draw the line y equals 2, then you get these solutions out. So the line y equals 2 is that line there. So your solutions are here and here. So I'm going to read off, go down to the x-axis, that's 3.5, and that is negative 0.5. Of course you'll be given a little bit of leeway, but certainly if you draw that line you're going to get at least 1 mark. Right, this should say x squared with a little superscript 2 there, take away 4x plus 1. Now this is a problem because we don't have the graph of x squared take away 4x plus 1. We've got the graph of x squared take away 3x. So if I just add x to both sides, you'll see that I've got x squared take away 3x there. And if I take away 1 from both sides, then I will be left with x squared take away 3x equals x plus 1. So just to explain that again, what I've done is I've added x and taken away 1 from the from the left hand side, and I've done the same to the right hand side. So if I draw a graph of y equals x minus 1 against this side here, then I will just see where they cross. So x minus 1, so it will be like this. So the y coordinate is always 1 less than the x coordinate. And you should see that those two lines cross here. So that is what is it? It's about 0.3, your value of x. And up here, so that's about 3.7, I'm going to say there. These two solutions, so 0.3 or 3.7. Last one. We've got another graph to produce, so x squared plus 2x plus 1. So start at the positive end. 3 squared is 9, 2 lots of 3 is 6, so it's 9 plus 6 plus 1, which is 16. 2 squared plus 2 lots of 2, so 2 squared is 4, 2 lots of 2 is 4, 4 plus 4 plus 1 is 9. This one is 1 squared plus 2 lots of 1, that's 1 plus 2, that's 3, add the 1 is 4. Interestingly, these are the square numbers and there is a reason for this. 0 plus 0 plus 1 is 1. Now for the negatives, we've got negative 1 squared, that's 1, plus 2 lots of negative 1, that's negative 2, so 1 take away 2 is negative 1, plus 1 is 0. Negative 2 squared, that's 4, plus negative 4, so that's 0 plus 1, and it's just going to go like that, and you can probably imagine what the next one's going to be. Negative 3 squared, that's 9, plus 2 lots of negative 3 is negative 6, 9 plus negative 6 is 3, plus 1 is 4. So it's symmetrical. So 0, 1, 1, 4, 2, 9, 3, 16. So it's really the graph of x, y equals x squared, but one space moved to the left. Negative 2, 1. And you study why that is in graphical transformations. Don't forget to draw your curve. There we are. Use your graph to solve that equation, so we're just looking for where y equals 4. So it's there and there. You can actually read this off your graph, it's just where x, off your table, because you've got where y equals 4, negative 3, 4 and 1, 4. You can see it on your graph here as well. So it was negative 3 or 1. Use your graph to solve that equation, so we've got to do some rearranging here. So we've got the graph of y equals x squared plus 2x plus 1, and we want to transform it into the graph of y equals x squared plus 2x take away 2. So if we had that equals 0, which we're given, we want to do something to this to turn it into that. So if we add 3 to both sides, then that is still true. So the only difference between here and here is we've added 3, here and here we've added 3. So we need to find out where y is 3 then. So we draw that little dotted line across from 3. The solutions are here and here. So that is what, about 0.7 and negative 2.6, something like that, that value there. And that's that.